Thermic reaction. Chemical reaction proceed with absorption of heat. Absorption of heat. So what is happening in this? The heat is getting absorbed, and actually a release also happened, but that's very less. So definition we can simply write here: chemical reaction proceed with absorption of heat. Example very common that we can see in our daily life is cooking of food. So cooking of food is an example of endothermic. Second one, we can write when ammonium chloride is dissolved in water, like NH4Cl. When it's dissolved in water, it gives out, this is endothermic, and salt dissociate into ammonium and chloride ions, and here then this NH4Cl, that is in an aqueous state, and obviously heat is taken in, so heat is taken in. So this is how we can understand about endothermic. And next one, in endothermic, we can write like this: endothermic. So absorption of heat is more, means activation energy is more, and heat evolved is less. So reaction in which a single substance decomposes to give two or more substance. So decomposition reaction we can categorize into three parts. One is thermal decomposition. Another we can categorize light decomposition. Next one we can categorize electrolytic decomposition. Electrolytic decomposition. So here the decomposition, why it's of three types? Because the cause, or you can say the energy source, is different. In thermal decomposition is due to, tell me, due to heat. Light decomposition is due to light, and electrolytic decomposition is due to electricity. So what we have observed here, the source is different. In thermal decomposition, because decomposition reaction happen when we need to break it. So obviously for breaking we need energy to break it. Okay, like if in common life, if you want to break something, you need either muscle power or you need some stuff, just to break it. So obviously you need energy to break it. So energy is needed for this reaction to proceed, and that's energy source are three types. Based on that, we have thermal decomposition. Here the source is heat. The light decomposition, the source is light. And electrolytic decomposition, the source is electricity. Now we have to take examples. In thermal decomposition, we can take an example of CaCO3, calcium carbonate. When it's been, here we can write heat, and this is calcium oxide plus carbon dioxide. So this is thermal decomposition. And then we have a light decomposition. So light decomposition, we can write AzBr. So silver bromide, when it's decomposes because of the light, then it's going to be Az plus Br. Br, it's a diatomic always, so Br2 we have to write, and we need to balance it, so it's 2AgBr and this is 2Ag. And after that, electrolysis, we have example, we can take it up about water also, and let's just go for H2O. We can electrolyte. After that, it's gonna be 2H2 plus O2, and this is 2H2O. So this is electric current is passed through. So we can write here electric current. So what we have observed here, three types we have seen, and in this, because of these different sources, we have the reaction that's happening. In your book also there are some equations given based on, so obviously you need to remember those reactions, is very important. After that, we have to go for displacement reaction. Another type is displacement. What is displacement reaction? Could you tell me what is displacement reaction? Displacement reaction, when one element, means one element displaces another element. Okay, one element, or you can say more powerful, more reactive element displaces less reactive substance. Now, to understand this, we have to understand which one is more reactive. So we have a metal series, so that we're gonna discuss today, and more working we do it in next session. But metal series or reactivity series that commonly we have to remember, or when you have to remember is what, like this is potassium, sodium, calcium, magnesium, aluminium, zinc, Fe, H, then Cu, then Hg, then Ag, and then Au. Now if you go from top to bottom, the reactivity decreases as we go from top to bottom. So you can say that this is most reactive. This is what? Most reactive. And this is least reactive. So this is very important to remember. Then only we can understand the displacement reaction, because we should know that in reaction which element can displace which. So for that, this series is very important. This reactivity series is very important. Example, and that is, let's say Zn plus CuSO4, Zn plus CuSO4, and if you're going to see, zinc is more powerful, copper is less powerful. So always what is happening, more powerful displaces the less powerful. So this will take its position and this will go out. So kind of is ZnSO4 plus Cu. So Cu has been given out and zinc sulfate would be the product. So this is the displacement reaction, how more reactive one. This is actually happening in common life also. If two of your friends, if one is more powerful and another one is you can say less powerful, and if they have to run and grab something, more powerful will reach first and grab those stuff. Same thing is happening here in chemistry also, in this reaction also. Okay.